We present Holoported characters, a real-time approach for free viewpoint rendering of humans from sparse views.
Hi, I'm going to present the paper Holoported characters, which is the method used to create me. By the way, I'm a virtual human created by this method. It takes in as input 4 camera views and is able to do free viewpoint rendering in real time for poses it's not seen before. Additionally, it generates 4K images, so you're able to zoom into my face really well while preserving a lot of the details. Thank you and enjoy the video.
Closely related to our problem setting are prior works focusing on the creation of animatable characters. One such method is DDC, which represents the human as a deformable mesh and dynamic textures. While their method achieves real-time performance, we observe that their synthesis quality is still limited, especially when viewing on high-resolution displays. Another more recent work is HD Humans, which is a hybrid explicit-implicit representation. While it can generate sharper images at 4K resolution due to its hybrid formulation, it is not real-time and it hallucinates wrinkles not present in the ground truth due to their adversarial training strategy. Recently, there have also been works on free viewpoint rendering given sparse camera view observations. NRF proposes an efficient free view rendering approach for general scenes using a radiance field representation. While their method achieves real-time performance, it exhibits view consistency artifacts because of its constrained color formulation. The most closely related work to our problem setting is DVA, which represents the virtual character as volumetric primitives that are loosely attached to a mesh. Although this approach achieves real-time performance and demonstrates consistency with ground truth data, we observe that DVA struggles with characters wearing loose type of apparel. Moreover, their result quality degrades when the model is trained and tested on long sequences containing more diverse and complex motions. To tackle those limitations, we propose Holoported characters, which takes 4 sparse camera views in a skeletal motion as input and generates free viewpoint renderings at 4K resolution at real time. Our approach further supports loose type of apparel, and, in contrast to animatable representations, it reproduces exact details such as face expressions and cloth wrinkles consistent with the input views. In more detail, we assume a rig template mesh of the actor is available as well as a multi-view capture of the subject performing various motions, with calibrated cameras. We then automatically extract foreground masks and skeletal motion. With this training data, we learn a sparse multi-view image and pose-driven character as follows. The input to our method is 4 sparse multi-view images depicting the actor, the respective skeletal pose, and a novel camera view. Next, we first train a skeletal motion-dependent character model, which takes the motion as input and predicts a pose-dependent surface deformation of the template mesh. We highlight that this model also accounts for loose type of clothing and fine structures like the hands of the human. In contrast to animatable representations, we want to encode the information provided in the sparse input images such as the wrinkle patterns into our model. The texture space of our template represents an ideal way to encode this information as it will be spatially consistent across frames and it enables the usage of efficient 2D convolutional architectures. Thus, we propose a projective texturing, which maps the sparse views onto the deformable mesh's texture space. Next, we also encode the input view direction in texture space, which helps to encode view-dependent effects. Finally, we render a temporal stack of posed normals maps in texture space to also efficiently encode the surface geometry and dynamics. These encodings are then fed into our TextNet model, which generates a dynamic texture map along with deep features. While this dynamic texture already provides a high visual quality when rendered into screen space, the resolution is still rather low and artifacts appear at the mesh boundary due to the explicit nature of meshes. Instead, we render the dynamic texture and the deep features into screen space and pass this feature image into our SRNet, which upsamples the feature image to 4K. The result is not only of higher spatial resolution, but the SRNet also effectively learns to handle the mesh boundaries and resolves undesired artifacts. Our TextNet and SRNet are supervised using 4K multi-view imagery, whereas the deformable mesh model is supervised on ground truth meshes obtained from the recent state-of-the-art implicit reconstruction method NEUS2. Here, we present the results of our method in the novel pose setting. Note that our method generates novel views for poses that have not been seen before. Above each subject, we visualize the virtual camera trajectory, which significantly differs from the training views, demonstrating the generalizability to out-of-distribution viewpoints. Moreover, we obtain view and temporally consistent results when the virtual camera view is changing. Please note the ability of our method to capture fine structures like clothing wrinkles and facial expressions while running at real time. Also, we would like the viewer to focus on our ability to capture hands well, which is vital for an immersive experience. Here, we present results in the novel view setting, where these skeleton poses are seen during training. Please note that despite being an animatable method, our approach can also do extremely high-quality novel view synthesis for the training frames. Please observe the effective capture of wrinkles and facial details. Here, we present a comparison to previous work on pose-driven animation. Notice our method generates sharper wrinkles and is also more consistent with the ground truth while running at real time. Here, we present a comparison against methods that are real-time and sparse image-driven. As can be seen, NRF suffers from view consistency artifacts due to its constrained color formulation. DVA struggles with loose clothing and suffers from blurriness. We also present comparison results on a virtual camera trajectory. Please observe the view consistency artifacts in NRF and the inability of DVA to model loose clothing. In the following, we ablate some of the components of our method. If we remove partial texture conditioning from our method, it is observable that the fine details, such as clothing wrinkles, are no longer present. Further, if we remove the SR module at the end of our method, we face rendering artifacts at the boundaries, as seen in this snippet. Finally, ours, with all the components, has graceful boundaries and is noticeably sharper. The explicit nature of our approach allows for some exciting applications. Here, we present a result where we add a logo to the character. The realism of wrinkles in our approach makes it suitable for immersive applications, as we can generate sharp wrinkles and even plausible facial expressions in real time, as can be seen in the free talking result here.
The method name is called the Deep Dynamic Characters, and which during the test times.
We thank you for your attention.